All right, so our last section in chapter 3 is elasticity of demand. Elasticity of demand. The first couple of slides are all set up. What is it? How we get the formula? But once we get to the formula, that's what I want to focus mostly on. Okay? So what is elasticity of demand? Increasing the price of a product can impact the revenue to the seller. The increased price may result in a sufficient decrease in the number of items sold to reduce the total revenue. On the other hand, an increase in price might lead to an increase in revenue. Economists use the notion of elasticity of demand to study the relationship among price, demand, and revenue. So let me back up a second. When you have a business, the number one thing that you can mess up is price. If you charge too much, nobody buys it. If you charge too little, flies off the shelves, you could have made more money. You got to pick the right price. If you pick the wrong price, everything gets messed up. And you have this basic idea that, okay, how do I figure out price? How much does it cost? And we can even see how cost is changing and all that. And then you add a little profit to it. That's how it works. Well, it kind of is a little bit more than that. If I'm selling an iPhone or if I'm selling a can of peas, that's two totally different things. If I'm selling an iPhone, can I charge more for it? Why? Demand. People want that. They want the new tech. And I know a lot of money goes into research and development, all that, but people want it. They can't wait for the next one. That's why they come out with one every year or every other year, right? But they got to be careful not to do it too quick. But people want that. How many people are flying to the store waiting in line for a can of peas? Nobody. So peas may be sensitive as far as price. If I raise the price on peas, I'll just buy corn. But the iPhone 11 or whatever one's coming out next, if I raise it $5, are you going to jump off the line saying, forget this, $5 more? No, you'll probably spend the extra $5. But it's getting up there a little bit where people are like, I don't know if I'm going to spend $800 on a phone or $1,000 on a phone, right? So you got to be careful. When iPhones first came out, they were too high. First, people ran in, they bought them, and then sales stopped or slowed down. So they had to give money back because they messed up on price. So this helps you figure out price based on how much people want. So the idea of this is relative and percentage rates of change. The relative rate of change of a function is the derivative function over the original function. Again, this is all leading up to the formula. We're not at the formula yet. It's equivalent to taking the derivative of ln of f of x, which if you look at how to take a derivative of ln, it's the 1 over the original times the derivative. And it's the percentage rate of change of a function. Then you multiply by 100 to find the percent. The alternative form of the relative rate of change is called the logarithmic derivative of f of x. So if a stockbroker tells you about a stock where each share increased by 45,767 from December 2016 to December 2017, you'll be like, I want that stock. It went up $45,000. That will get your attention. But somebody else said, I have stock that went up $59. You may not be that excited. But keep in mind, that is all relative. Just because it went up 45,000 or went up 59, it depends on how much the stock started at. So if I tell you that the stock that went up $45,767, one share cost $249,000. Did you buy one? Probably not. The one that went up $59 was only $113. So if we look at it, if I paid $113 and went up $59, that's over half. But if I paid $249, that's not over half at $45,000. So it's all relative. That's the idea of this. And if we want to compare the relative rate of change, we take the price change over the price of one share. So for example, the first one, yeah, it went up 45,767, but the original price was 249,711, which is 0.183. The other stock went up 59.37, but it really was 113.30, so that's 0.524. Notice that it's higher. So it would have been smarter to buy more of the $113 shares than to buy one of the 249 shares. And you would have made, if you bought the smaller stock, if you bought that much, 249,711 worth of the cheaper stock, which is 2,204 shares, you would have made $130,000 increase. So the bottom line of these slides is it's all relative. It's all relative. And so the table of the GDP, gross domestic product, expressed in billions at $2,005, and the U.S. population from 2000 to 2012, This one shows how it's changing. So if I give you a linear model, if I took that data, put in the calculator, did linear regression, I get f of t equals 209.5y plus 11,361, where t is the number of years since 2000. And I want to find and graph the percentage rate of change. How do I go from data to the linear equation to eventually the formula that we're going to end up with? Here's how we do it. So remember it was 100 times, because we changed the decimal to percent by multiplying by 100. We take the derivative of the ln of that model, and that gives me the 20,950 over the original 209.5t plus 11,361. If I graph it, even though it's going up, how it's changing is going down. So even though things go up, the rate of going up is actually slowing down. It's going down. So this gives us a deeper look. This gives us a deeper look. So the elasticity of demand is used by economists to answer the question, when does an increase in price lead to an increase in revenue? Bottom line, I choose a price. Is it the right price? Should I go up or should I go down? This will help us answer that question. So we're looking for elasticity of demand. P is price, X is demand of a product, related by the price demand function, X equals F of P. And what we're finding is the elasticity of demand at price P, EP equals negative relative rate of change of demand over relative rate of change of price. Now, again, we're not in the formula yet, but we're getting very close to it. What this will tell us is, number one, the change in demand over the change in price. How demand changes and how price changes. Now, if these numbers are different, you could have made a mistake. What do I mean by that? And I'll give you some examples in a minute. If one number is higher than the other or lower than the other, then maybe you shouldn't raise it, maybe you should lower it. So this all tells us. And notice that the formula starts with negative. A lot of people miss that. A way to remember that, it's connected but not exactly connected, but a way to remember the negative in the front, a way to remember it is that if you increase price, will you lose people? Yeah. So the negative means you're going to lose, right? If you raise, it's connected, but a good way to remember. Okay? So it's the relative rate of change of demand over the relative rate of change of price. If we work our formula, work it out, we end up with this formula. This is what I want you to write down. So all those slides are set up to find the elasticity with respect to price. It equals negative. It starts with a negative. P stands for price. F prime of P is the derivative of the function over the original function. Okay? That's what we're going to use. And all those slides leading up to it is how we got there. Okay? So that's the formula. Now we're going to use it. Okay? So the question is my price good? If I plug into this formula, I can find out if my price is good, if I should lower the price, or if I should raise the price. Lower the price or raise the price. Okay? So we have a problem here, but before we work on any problems, I want to give you some setup. But what we're going to do is plug in prices and find out if it's right. We're going to plug in prices, find out if we should raise or lower the price. But before we get there, I want to skip a little bit. I want to talk about this. The result. Okay? You're going to plug in a price and you're going to get a result. That result is going to tell you what to do. Okay? So there are three options that your result can be. Option one. Your result will be less than or greater than 0, between 0 and 1. I'm just going to say, to make it easy, lower than 1. If your result is lower than 1, you are inelastic. Okay? Inelastic means you should raise the price. So if your result is less than 1, you are inelastic, you should raise the price. So here's the basic understanding, and then I'll give you a more complicated. I just want to get you to the basic understanding. If you get the complicated, fantastic. But the basic understanding is, if your result, after plugging in a price, is less than 1, you are inelastic. And the result is raise the price. If you raise the price, you'll make more money. Okay? Increasing the price will increase the revenue. Now, if your result is greater than 1, if your result is greater than 1, you are elastic. If your result is greater than 1, you are elastic. So you should lower the price. If your result is greater than 1, you are elastic, you should lower the price. If your result is greater than 1, you are elastic, you should lower the price. Now, let me stop a second and see if you can figure out the connections. If I am lower than 1, I should raise the price. If I'm higher than 1, you should decrease the price. So what do you want to get? You want to get 1. And at 1, you are unit elastic. At 1, you are unit elastic. At 1, you are unit elastic. Okay? And what that means is we get 1 over 1. The change in the demand is the same as the change in the price. Change in demand is the same as change in price. But bottom line, if you get 1, that's the best price. If you get 1, that's the best price. You are unit elastic. Okay? Questions so far? You have all the setup. Now it's time to work on some problems. Okay? And remember I told you I gave you the basic understanding? The basic understanding is if it's less than 1, inelastic, raise the price. Greater than 1, elastic, lower the price. Your job is to get 1. Just to remind you a little bit, the top number is the change in demand. The bottom number is the change in price. The top number is the change in demand. That's going to help us with the explanation. The bottom number is the change in price. Okay? So here's our first problem. Okay? X is demand, P is price. X is demand, P is price. So we start with this equation. Okay? X is the demand, P is the price. Now, let me add just a little bit. When I say demand, what does demand mean? Demand means how much people want it. Demand means how much people want it. And what I mean by how much people want it, demand is a quantity. How many? If I sell it at this price, 100 people want it. If I sell it at this price, 80 people want it. Okay? So it's technically quantity demanding. Step 1, we want our equation to be x equals. Step 1, we want our equation to be x equals. So if we want our equation to be x equals, we're going to subtract 500p, subtract 500p, x equals 10,000 minus 500p. So that's step 1. Okay, we want it to be x equals. And if you want to put it in function notation, instead of saying x, I can say f of p. They're the same thing. It's still demand, but now it's a function. So how will these problems start? You'll be given the equation. What's p again?
Price.
Price. And what's f of p? F of p is x. X is demand. How many? Are we okay? Now, my question is, should I charge $4, $16, or $10? Well, to figure that out, we first have to do elasticity of demand function. And here's the formula you need to know. EP equals negative, always a negative, P for price times the derivative of the function over the original function. That's the formula you need to know to find elasticity of demand. We're going to go through that very slowly, make sure every part makes sense. We're going to go through that very slowly, make sure every part makes sense. So you're given this equation, and you know the elasticity of demand function, okay, the formula. So we're going to go very slowly. Please stop me if you have any questions. So to find the elasticity function, how does the equation start?
Negative.
Negative. Don't forget that negative. If you forget the negative, it changes everything, it messes up everything. Be careful. Okay? P is just price, so we just put P. P is just price, so I just put P. Any questions so far? What's the next part of the formula? Derivative of P, right? The function, derivative of the function. So what's the derivative of 10,000? And what's the derivative, be careful, minus 500P? Perfect. Any questions there? All over what? The original function. Stop there. Any questions on how I got that? Nope. I'm going to give you P soon. Okay? Can I clean this up a little bit?
Yeah.
Negative times negative is positive. 500P over 10,000 minus 500P. There is your elasticity function. I'm going to stop there. Give you a second to look at it. Any questions? Any questions? Yep.
Just to make sure, so how do you, the negative P, the negative factor, you just multiply it, right? Like,
Yeah, I took that negative in front, multiplied by the other negative, and made it a positive. I could have left it like this, but it's just two negatives that become a positive, so I don't want to mess with it later. And then that's the whole point of cleaning it up, is that it's simpler to deal with, Now, I'm going to stop there for a second. I will tell you that in the notes, and there are people that want to simplify further, just watch for a second. I have 500P. I can pull out a 500 from the bottom, and I'll be left with 20 minus P. 500 and 500 will go away. And I'd be left with P over 20 minus P. Okay? So either one. You can use 500P over 10,000 minus 500P, or you can simplify it further and call it P over 20 minus P. Okay? 20 times 500 is 10,000. I factored out. Okay? Now, which one do you want to use? Doesn't matter to me. Which one do you want to use? Do you want to use the first one or the second one? Okay, we're going to use the first one, but understand this is exactly the same. It's just a little simplified further. Are we okay? But I have no problem using this one. Okay? They're the same. They're the same. So I'm going to ask you, hey, should I charge $4? Should I charge $16? Or should I charge $10? Okay? Should I charge $4, $16, or $10? Now, I'm a little lazy. I don't know about you. I don't want to sit here and type all that in. So what could I do? Go to Y1, put this equation in. Put your elasticity demand equation in. Now be careful. Make sure the bottom has parentheses. If you don't put bottom, the denominator in parentheses, you will get the wrong answer. And then plug in 4, plug in 16, plug in 10. And then look up, see if you got the same answers. So in Y1, we're putting 500x divided by parenthesis 10,000 minus 500x. Then go to your table feature, which we've used a lot, and see what answers you get. when you're done, then we went to the calculator in Y1, we put the equation, that parenthesis does matter. Then I went to the table, I plugged in 4, I plugged in 16, and I plugged in 10. Are we okay? Now, I'm going to give you the basic idea, which is what you need to know, and then I'll give you the more complicated idea, which is just nice to know. So, when I plugged in $4, I got a result of 0.25. Is that inelastic, elastic, or unelasticity? That's inelastic because it's less than 1. And what's your advice when it's inelastic? Raise the price. So basically, if you charge $4, you're losing some money. You could potentially make more money. You could potentially make more money if you raise the price. $4, too cheap. Are we okay? Now, this is the complicated explanation. Don't stress about it, but just kind of appreciate it. I wrote 1 over 4. 1 over 4. And the reason why that's where it comes from. Remember, the top number is the change in demand. The bottom number is the change in price. Top number change in demand, bottom number change in price. And remember, the formula always has a negative in front. This is telling me if I raise the price 4%, I would only lose 1%. Why am I saying lose? Because the formula has a negative in it. The formula has a negative in it. Don't have, it's nice to know, but not essential. If you raise the price 4%, you'd only lose 1%. So does that make sense? If I raise it 4, I only lose 1. That's a good thing. That's why I should raise the price. Okay? And again, don't stress too much about it, but that's the why. So you're like, raise the price, no problem. I'm going to raise it to $16 each. Well, what happens when you get 4? Are you elastic, inelastic, or unit?
Elastic.
You're elastic. You should what? Lower the price, greedy. That was too much. Okay? And the reason why it's elastic, it's above 1. When it's above 1, now you need to lower your price. So $16 is too much. Now again, the complicated one that's nice to know. If you raise the price 1, you'll lose 4% in demand. That's not good. Raising it 1 but losing 4. You're raising it 1 but you're losing 4. Raising it 1% price, losing 4% demand, not good. And then magically, when you plug in 10, what do you get? 1. That's where you have unit elasticity. That's the best price. And why is it the best price? It goes back to the definition. If you charge $10, you increase 1% in price, but you only lose 1% in demand. It equals out. Okay? So what you need to pull from this is, if it's less than 1, you're inelastic, raise the price. Too cheap. $4, too cheap. $16, you got 4, it's greater than 1, you're elastic, lower the price. But when you charge 10, that's the best price. Now, I do want to point something out. Isn't it lucky that the third one gave you exactly 1? Are you going to sit there with your calculator, type in 4, 5, 6, 7, 8, 9, 10 is the answer? Doesn't that take forever? So the bottom line is, once you have this equation, what output do you want? What output do you want? 1. So I could have skipped all this work. I could have skipped all this work, and I could have said, I know that my demand is 500p over 10,000 minus 500. Once I have that demand, once I have that elasticity demand function, what do I want it to equal? 1. Then I need to solve for what? Algebra, 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 algebra. So I'll walk you through. But do you understand that I want this function to equal 1? That's the goal. That gives me the best price. So to find the best price, you set the equation, the elasticity demand equation, equal to 1. Are we okay? So algebra, algebra, algebra. Can we agree that 1 is really 1 over 1? Can we agree there? And how do you solve a proportion? Cross multiply. 500p times 1 is 500p. 10,000 minus 500p times 1 is 10,000 minus 500p. I'll give you that as a head start. You solve for p. And you already know what the answer should be. What should the answer be? 10.
So always cross multiply.
How do you solve a proportion? Cross multiply.
When you say proportion,
Proportion is a fraction equal to a fraction. Something over something equals something over something else. That's a proportion. So I could have skipped all those steps. And just found the best price. Okay, to solve this, add 500p, add 500p, 1000p equals 10,000, divide by 1,000, divide by 1,000. What's the best price? $10. Okay, stop there. Any questions? I'm going to add a little bit more, and then we're going to do one example from the top. I'm going to add a little bit more, and we're going to do one example from the top. Okay, so we found the best price. What if I ask you, question 1, what is the quantity demanded at the best price? So if I now know I'm going to charge $10. If I now know I'm going to charge $10, how many am I going to sell? Where would I find that answer? Would I plug it back into the elasticity of demand? Nope, that's going to give me 1. Where would I plug it into? The original function. Remember, the original function tells me quantity demanded. All I need to figure out is the best price. And what's the best price? 10. So now I can plug in 10. And how many will you sell? How many will you sell? 5,000. We didn't talk about what this is. 5,000 stuff. We'll do a better word problem next time. Now, I'm not done. Let's say this is, what's something you could buy for $10?
movie bag.
Movie bag. Where you buy that? How about a sandwich? Okay? So if you sell your sandwich for $10, you'll sell 5,000 sandwiches. Last question. What will your revenue be? If I know I'm going to sell it for $10, and if I know I'm going to sell 5,000 sandwiches, how much money am I going to make? Revenue will equal what? What do I do with those two numbers? Multiply. Each one is $10. How many am I going to sell? 5,000. So how much money will I make? $50,000. That is a complete elasticity problem. I added a little bit to the notes. We're going to do another example in a minute. Don't worry. But once I find the best price, I can then find how many, and then I can find my revenue by taking price times demand, which is what we learned before. We okay? So look at this one from top to bottom. Look at this one from top to bottom. I'm going to give you a whole other problem to do. A whole other problem to do. From the top. And then we're done. Okay? So we're going to review everything we just did with a brand new problem. So f of p equals 1875 minus p squared. F of p equals 1875 minus p squared. P is price of a t-shirt. F of p, which is also x, is your quantity demand for the t-shirts. And then here's what you're going to find. Number one, find the elasticity of demand function. Question 2. Then you're going to plug in f of 15, talk about it. F of 25, talk about it. F of 40, talk about it. Then I want you to find the best price. Even if you already found it, find the best price, do the algebra. Even if you already have it, practice that algebra. Then question 4, find the quantity demanded at the best price. And 5, find the revenue. That is everything that we can do with elasticity. Okay, I'll walk around if you need help, but I'll give you some good time. And then we are done with chapter 3. We're going to start. I'll walk around a little bit. We're going to start first. What? That is 40. whole way. You can do this, you can do elasticity at the end. It's one thing to be able to follow along, another thing to be able to do it. In about a minute, I'll work out the demand function, just so you can check if that's right, because if that's wrong, everything else. So the elasticity of demand function. That function is wrong, everything else. This one doesn't simplify it further. You can always use it as calculus. And remember, when you use your calculator, the denominator should be in parentheses. The denominator should be in parentheses. Little mistakes. All about the details, all of that, calculators, got it, check with the neighbor, see if we got the same answer.
Oh, I think I'm expecting one. That's why, but.
Good,
Got it.
algebra's good, now you just gotta get the concept.
Yeah.
It's another minute or two, most of you guys are getting to the end. problem, maybe not one of these from start to finish. Also, the other example is a create a problem with like a special case derivative problem, either one. This to me is a nice one for to create a problem. Change the number of things, make sure it all works. All right, so if we have the elasticity function, now it's just being careful. I go to my calculator, I go to y equals, I put 2x squared divided by parentheses 1875 minus x squared, close parentheses. Go to the table feature, plug in 15, plug in 25, plug in 40. So you get 0.27, you get 1, and you get 11.64. When it's less than 1, what's it called? Inelastic. And what it means is you're not so sensitive, and you should raise the price. When you get 1, that's unit elasticity. That's when you know you have the best price. But keep in mind, we got lucky that it was 25. You don't want to sit there and just keep plugging in to get 1. And then when you're greater than 1, you're elastic. You should lower the price. Now again, the reason of lowering and raising and all that stuff, the reason why we do it is to increase our revenue. If you lower it, you'll make more money. If you raise it, you'll make more money. And 25 seems to be the best price. Now, if I don't give you the numbers and magically you get 1, how would you do this? Well, we set our elasticity of demand function equal to 1 over 1. Zoom in on that part. Cross multiply 2p squared equals 1875 minus p squared. Add p squared, add p squared. Some of us are struggling with the algebra. 2p squared plus 1p squared is 3p squared equals 1875. Divide by 3, p squared equals 1875 divided by 3, which is 625. But I'm not looking for p squared. What am I looking for? P, so square root. It technically gives you positive or negative, but price has to be positive. So what's the best price? $25. And as you already know, if you get 25 and you want to check if you're right, plug it in to the elasticity and it should equal 1. And it does. Question?
No.
So be careful. But the good news is once you get 25, plug it into the function, the elasticity demand function, and you get 1, so you know you did it correctly. Algebra. Then, if I know my best price, how can I find out my quantity demanded? What would you plug it into? You plug it into the original function, and I now know my best price. And this doesn't tell me the price of the t-shirts. This will tell me how many t-shirts. So how many t-shirts will be demanded?
1250.
What is it?
1250.
1,250 t-shirts. So if I know that the best price is $25, and I know that I'm going to sell or quantity demanded is $12.50, how much money will I make? $31,250. That will be my max revenue because I chose the best price. Okay?